So, thanks for introduction. Uh, can I get my remote working somehow? It doesn't change slides. Ah, yeah. So let me first say that it's okay. Normally I do technical talks or very technical talks. So that talk is not gonna be technical, and that means that lots of things I'm gonna talking about today is subjective, which means that I might just be wrong, or there might just be no definitive answer. So don't get sad if you don't agree with what I'm saying. So I wanted to talk a bit more about some slogans today that we have in our industry, such as internet security. Internet security. We have internet. We talk about internet security everywhere. We have internet security companies and jobs, etc. But what is really internet security, and is it really where we should be focusing our efforts? Another question or slogan is, human is the weakest link of security. And so we can just give up on all the technology advances. We should just focus on the human. However, we cannot focus on the human. It's hopeless. Everything is hopeless. Thank you. Another slogan is, we need more security experts to rescue the situation. In fact, this very gathering of people right now is because people think this is what we need. So I'm gonna sort of question these slogans today and also provide some more thoughts. So we want to secure the internet, obviously. We live in a society where internet or computers becoming increasingly more important, and in order for this not to be a Wild West, we want to secure the internet, right? But what does it really mean, secure the internet? Sure, there is some reliability aspect of the infrastructure, like we want it to work. However, the more important aspects that usually we think when we talk about internet security is things such as prevent eavesdropping of our data, or prevent somebody from spoofing our actions online, so identity theft, etc. Or owning our devices, so code execution prevention. If we look at especially these three things here, it's probably, we'll get to a conclusion that it's likely not the internet we want to secure, but our devices, specifically end user devices, client devices, laptops. So that's an important difference that I have an impression that lots of people kind of miss, that it's our devices, the endpoint devices, that are the most critical thing that we should be thinking about how to secure. Because client systems really are our eyes, ears, and fingers, by which I mean they can see every document, they can hear what we do over VoIP, and they can spoof our actions using simulating keyboard or mouse movements, whatever. Surprisingly, large number of people do not realize these simple, obvious truths, that if our endpoint device is compromised, then essentially everything is lost. We cannot have reliable crypto if our laptop is compromised. Now, some crypto zealots might say that's not true because we use hardware tokens, and with the hardware token, even your Windows can be compromised. A private key on your hardware token is still secure. That's true. However, if we think about it, it's not really the private keys that we should be concerned about. It's the documents, the data that are to be secured. And the document always gets decrypted, finally, to be shown on the screen for the user to see it, because the user cannot decrypt it on the fly in their retinas or whatever. Two-factor authentication is the same. So people always say, okay, this Windows might be compromised, but when I log into my super sensitive nuclear power plant controlling system, we require two-factor authentication for that, so that's secure. That's not true, because the malware that compromised your laptop might just sit and wait until you log in, provide all the two multi-factor authentication, and only then, once you're finally in, once you jumped all through all these jump posts, and only then, in the right moment, inject some keystrokes on behalf of you. And there is no way for the server on the other end to know it was not you, but just your malware that just hooked your keyboard driver. And it's the same argument for the VDI, thin client solutions, for the people who think, let's secure the cloud, because the cloud is where our data are, and forget about thin clients. It's not gonna work. So I think Richard Stallman lecture yesterday, presentation, and he mentioned freedom. How important is freedom? And that we cannot have freedom without ability to choose software that we run. Of course, I agree. However, I would add that not only we need ability to choose software, we also need ability to control what the software does. Lots of free software people think that their free software will always do what they think they will do, and that's obviously not true, because once the, however free software gets compromised, now it's executing the attacker's shellcode, for example, and it's doing completely something different. So controlling what we install or what programs we start is one step, but the other step is to control what those programs really do. And that we also cannot achieve without secure endpoint devices. So I'm sorry, do I have a clock here that I can control time? No, because... Okay, just if somebody can give me a clock, that would be nice. So then bring us to another aspect, which is human factor versus technology factor. Again, I always see lots of misconceptions about the human factor. So the obvious one goes, users are dumb, they are the weakest link, and whatever technology, whatever secure technology we come up with, it's not gonna work because users are dumb anyway. Everything is lost, thank you. And this is sort of associated with another fallacy that people say, like people like you probably would be good candidates. I'm trained in security, I'm a security expert. I don't do stupid things on the internet, so I'm secure. I don't open attachments, I don't go to malicious websites, right? Or even perhaps I use Mac or Ubuntu, so I'm better than the other guys who use Windows. So how many of you use actually Windows, just out of curiosity, as your primary laptop? And how many of you use Mac? And how many of you use some Linux distribution? Uh-huh. Any people use cubes, perhaps? Uh-huh. So that's my favorite fallacy. I'm trained in security, I don't do stupid things. So my question to you then is, does your laptop has Wi-Fi? And note how I did not ask you, do you connect to untrusted Wi-Fi? Because this is irrelevant. If you have Wi-Fi, if you're using monolithic operating system, which keeps your Wi-Fi stack as part of the TCB, the Trusted Computing Base, it's completely irrelevant whether you connect or not consciously. You go to an airport lounge, and somebody might just send you a malformed Wi-Fi 08211 packet that just might happen to exploit the hypothetical bug in your Wi-Fi driver or Wi-Fi stack. Or perhaps inject you a malicious DHCP handshake. You might have heard about shell shock or shell bug a few weeks or a month ago. No action required from the user. Does your laptop have USB port? Again, I'm not especially asking if you plug in malicious USB devices, just do you have USB? Do you leave your laptop for a moment with a screensaver and go to make a coffee? Perhaps your colleague might come in and plug in a USB device that will exploit a USB stack processing code that has a bug with processing your metadata about the USB device. If so, the attacker gets to the kernel, TCB, the game is over. Of course, you use a web browser. Again, you don't need to use a malicious web browser. Maybe you are in a lounge or in a hotel or at a conference like that, and somebody just injects you something malicious into your legitimate news reading traffic. Of course, you open email attachments. So it's important to realize, especially for you security experts or security experts wannabes, that you really can get owned even if you think you don't do stupid things. And recent months, if you read the press, even the mainstream press, has just been lots of examples of how this happened to all sorts of people or industry or corporations. So humans, we, the users, are indeed a very weak link in security. But the technology is no better. And that is particularly something that annoys me because I'm a technical person. So a few years ago, when I was working as an offensive security researcher and been researching all sorts of virtualization or other attacks, or before that, as a malware researcher for Windows, I've been so annoyed that I might be looking at all this complex malware, complex attacks, writing proof of concepts for these, and yet I still might be owned so simply without my conscious consent for that. And the technology mostly means the end-user systems, because end-user systems is really where our digital lives are happening. Sure, they're happening partly in the cloud as well, but in the cloud only happens what we decide to send there. On my laptop is everything. So can I get this clock somehow? Sorry, I don't have any clock here. What time is it? That was my social engineering to get Van Houser's phone. So it's counting down to, okay. So what should we do with all that? So here comes another popular advice. So we need more security experts, obviously. And we have gatherings like that. So let's think about who are those security experts really? When we say security expert, when you say security expert about you, so there are all sorts of other terms like hackers. What is a hacker? It's really a mystery to me. It's my impression that these days everybody who learns some Python or writes an Arduino LED blinking thing calls themselves a hacker. So I try not to use the term hacker because it's so vague. Pen testers. Who are pen testers? Pen testers are like soldiers. They run Metasploit? Do they do any useful work or not? Or maybe researchers. And here we have offensive and defensive researchers that are topics of the next slides. Bug hunters, exploit writers are examples of offensive researchers. But perhaps by security experts, we just should understand developers of secure products. So I'm coming from an offensive background, so I'm naturally biased here. However, I work on a defensive project for several years now, so I believe I'm kind of more or less neutral. And so one of the opinion I have is that it's important that whoever wants to build a security product or technology should really understand offensive security. Because people who do not, people who have never written an exploit, never written malware, or at least analyze it in depth, they are prone to many fallacies. Depending who are those people, they might be saying things like, no, okay, we understand there's a bug here, maybe it's not perfect, but there's no way this is gonna be exploited in practice because this is just so difficult to them. On the other spectrum, the same people or other people without offensive background might just say, no, we understand everything can be exploited. It's just no way we can build any security. We should just give up, destroy our computers, move back to using papers and abacus, whatever. That's another dangerous thinking, in my opinion. Because it implies this kind of popular approach, which says, yeah, okay, we know it's not perfect, we are doomed, really, we will never win with NSA, GHQ, but we just want to have this little small improvement to raise the bar a little bit. I find this thinking extremely annoying, actually, because I personally really see no reason to spend time on developing solution that we immediately can see how it can be bypassed. If I know I'm doing something that the next week can be trivially circumvented, it just makes no sense, at least from the technical point of view. It might make sense from the business point of view or PR point of view, but from the technical point of view, it's just plain stupid. That's why I think that the second fallacy is dangerous, because it stimulates this third fallacy. And other people recently, especially in the recent years, where we have this hardware virtualization on PC, so there is this new trend of people saying, no, software is crap. We cannot have security enforced by software. We need hardware-defined security, like hardware virtualization enforced security, hardware virtualization enforced isolation. It's really annoying, because there is really no way we can get rid of the software out of the equation. And if we look at how traditional operating systems have been built for a few decades, all of them, or great majority of them, have already been using hardware enforced isolation. Because what is really process isolation or user mode kernel mode separation? It is hardware enforced isolation between ring 3, ring 0, or between different process address spaces enforced by the processor MMU. This isolation, which has been introduced on our PC processors in the 80s, 8386, the first processor introducing protected mode, hardware enforced security. It's been there for decades. And this hardware isolation has never been bypassed. At least I'd never seen a public exploit for it. Yet we know that all the traditional operating systems are totally insecure. Just a few slides ago, I showed you that slide saying, oh, so you think you don't do stupid things, but you have problem with Wi-Fi, USB stacks, etc. So how come? We have this super, as I say, super secure hardware isolation in use for decades by traditional operating systems, yet I'm just saying these traditional operating systems are crap. They are, because it's not the isolation that is weak. It is all the glue, all the integration that every operating system provides. All the syscalls, all the file systems that are implemented in the kernel, all the USB stacks, all the graphics subsystem. And this will always be software. So if somebody tries to sell you a product and say, oh, this is super secure, it uses a compartmentalization enforced by virtualization. Okay, it might be a good solution. Our CubesOS also do that. However, the question you should really be asking, okay, so how do you do integration of those separated compartments? Because it's integration. How do you GUI virtualization? How do you inter-VM communication? So as I say, people who never written an exploit don't feel security, in my opinion. And they easily come up with wrong, in my opinion, speculations. And that's dangerous, because that moves our industry into wrong directions, directions that do not bring us reasonable security. Yeah, another approach which I have not put on the slides is the academics with their approach that everything should be ideal, and they spend years coming up with those formally verified microkernels, which then turn out not to support IMMU, which is just not very good for security. Okay, so it's, as I say, great to be a security, offensive security researcher, as we just seen. But the question we should now ask, do really the offensive guys help the industry? And so should we really somehow make more offensive guys? In my opinion, the offensive researchers do not directly actually help us. By which I mean, surprisingly, in contrast to what you might be expecting, so we have this exploit writers, malware writers, you would expect them to come up with secure product. They don't do that, with very few exceptions. And that's because hackers just gonna hack. And that's because offensive research, exploit writing, malware writing, attacking systems is just fun. It's just exciting, challenging. And everybody really admires people working on the offense. Whatever they might be saying, they really admire or find them formidable. And that's another cool factor. Also, offense usually does not require that much code maintenance, bug fixing, support for users who are dumb. Well, if you work on a framework, that might not be that true, like you want to write a metasploit or something like that. It might require some parts of it, but probably that would be done by the other people, not by the offensive rockstars. And also, let's be frank, there's very good money to be earned by skilled offensive people working for different front-end companies. While at the same time, defense is just usually boring for most people. Okay. It also requires lots of not exciting work, which I have been especially witnessing with our work on CubeSOS. Like all sorts of things for your product or technology to actually work, which is not directly connected to exploitation, malware architecting. It's just the need to support the GPU to work or some scripts to get started so some application works, etc. It's just not exciting. And more importantly, people do not appreciate security solutions if they work correctly, because security solutions that work are mostly invisible. Like, do you really appreciate a traction control in your car? Probably not. Probably your traction control system might engage in 0.1% of the time you drive your car, depending how you drive it, but, right? And only in winter, and so we don't really appreciate it that much. We would appreciate more if it has leather seats and heated seats and whatever other head-up display, right? These are cool things, easy to appreciate, but not the safety in that case. And the same with security. I use cubes on my laptop. I think I have not been compromised. I cannot prove it. I just don't see evidence for that. And it puts me into a mood that, okay, so maybe it's an overkill. Maybe I could have just used Mac. It has such a nice GUI and, you know. And finally, probably the most disappointing fact about defense is that which is related to the previous one, is that it's so difficult for non-specialists to tell apart meaningful solutions from snake oil, from useless, meaningless solutions, like signature-based detection of malware that can be trivially circumvented at will, and we have known about this for 20 years or more. That's really disappointing. It's really demotivating. Well, you have 20 solutions, security solutions, and you know that people who come to choose one, not necessarily buy, just choose one, they have no clue how to tell which, and the one you work on is better than the others. It's extremely depressing. And compare this to working as an offensive researcher. I write an exploit for targeting product X or technology X or whatever, or undetectable malware. And I can easily show it, prove it. Nobody gonna doubt it because I can show it works. For example, it shows me calc.exe, right? Or shellcode, whatever. That's what makes offensive people more self-confident than the defense people, by the way. So seeing how unattractive defense might be to somebody who has been working on the offensive side, maybe we should ask a question to maybe forget those offensive people. We will never get them to the defense. Maybe we can just build security products without their help. But as I sort of tried to imply before, people who have no understanding of offense, like first-hand experience with offense, in my opinion, will never build good security solutions. Solutions either will be naive, or they might not even be naive, but targeted into solving not the most important problems. Like, for example, addressing the problem of cooperative cover channels in between VMs, while not really taking care about DMA attacks, for example. So maybe we should actually think about turning breakers into builders. But then again, defense is not exciting. That's the primary obstacle in doing that. And there is also another aspect, which is completely non-technical. However, I think it is important. So there's the feeling of empathy towards the user. I think defensive people are characterized essentially by lack of empathy to the user or to other people, mostly. That's really problematic because we really want to build a solution for people. And if we don't have this empathy feeling, our solution will get compromised by this human factor, which is another depressing thing because we might have just invested lots of work and energy into building some good technology. And then we will just sit and look how those people who get it don't understand it, don't know how to use it, will just use it wrongly, they will get compromised, and then we will read in the press how our technology is just a crap. Can we teach empathy? No. Yes, so this is just this summary. Offense is exciting because it's directed mostly by narcissism. It's and challenge provides good money, while the defense is boring, stable job. It's either naive or is characterized by pragmatism, and it's also fueled either by money or empathy. Money that think about antivirus, empathy think about all those activists, freedom fighters. They might be good people wanting really to do something for other people, but in my opinion, often they might be lacking technical skills to make their solutions effective, which is very unfortunate. Ideally, we would like somebody from the intersection of these sets, but that's a problem. In my opinion, you cannot be at the intersection at the same time. So I don't believe into really widespread campaign to turn breakers into builders for the reasons I just outlined. Even worse idea is to turn builders into breakers. It's just not gonna work. And even more terrible idea is to turn career seekers into breakers or builders, whatever. Yeah, there's so many people sending me emails like, "Hi Joanna, I would like to be a hacker. Can you recommend me books or something?" It's just not gonna work. This is not how you become an expert in either of the discipline. If the career is your motivation, I don't think you will be of much use to any of the camp. So what should we do? Well, obviously we should recognize this. Defense is not offense. Try to appreciate the work done by both people. Don't try to superficially move people or direct them or direct yourself. Like you read that, oh, there are so many job openings for exploit writers or whatever. Oh, okay, so maybe I should become one. Probably that's not gonna work. And most importantly, I think the last one is create attractive opportunities for the offensive people to somehow, so that we as a society could profit from their work instead of having them working for the dark side. There are actually few examples of that, but this is happening. Like certain large internet search company has a very strong security team, and they write detailed articles about exploitation. So that's mostly good. It's mostly good if the attack is, meaningful, but probably not so good if they attack each and every meaningless software, but that's another story. Yeah, so, okay, so we recognize we have offensive guys, defensive. We should somehow make sure they work together and build security. So should we now be really, should we really be aiming towards building a cyber army? Building a cyber army is another slogan very popular in the recent years. Which I'm skeptical about. Because a cyber army, which implies lots of people, like a mass approach, it's kind of another wrong approach in my opinion, because we really do not want to analyze each and every piece of malware. That's pretty meaningless. There can be a gazillion different binaries of malware. And what does it really give us? Not much. Or look for bugs and write exploits for each and every possible software the user might install on a system. Sure, that might be fun, but it doesn't really solve a solution. So what I'm trying to say, we should not really try to go into numbers. Yeah, we have analyzed 5,000 different pieces of malware, and we have 300 0 days. But one thing I believe we should be kind of alert about is when we try to profit from the work done by the offensive researchers, we should make sure we really can profit from it rather than just have the offensive people have some fun. Because for offensive person it would be fun to just write another exploit, even though it might just not change anything, because they might just be excited about, it was much more difficult because the ASLR was more random there, or NX was this and that. So, but ultimately, this might not really change our look at the field. So rather try to move the offensive people to focus on really important problems. For me, for example, from the project that I'm leading, it would be interesting for more people to look at the hypervisor security, especially something like Zen, and not necessarily coming up with yet another flash exploit. And for that, we don't really need a cyber army. We don't need numbers. We need just smart people and good motivations. And of course, I must have mentioned CubesOS here. So one of the suggestions to answer what should we do, how about helping us with CubesOS? And because this is videotaped, here's the CubesOS master key fingerprint. Lots of people on our mailing list asked me to read it out loud on some conference. So I'm just gonna do it right now for the record. So Cube's master key fingerprint is 427 Foxtrot 11 Foxtrot Delta 0 Foxtrot Alpha Alpha 4 Bravo 0 8 0 1 2 3 Foxtrot 0 1 Charlie Delta Delta Foxtrot Alpha 1 Alpha 3 Echo 3687 904 904. And that was Cube's master key fingerprint. So thank you very much. If you have questions, I think we'll have a microphone. Thanks.
Hi. Thinking about the security, what's the dark side means? What's the dark side?
I work for, as I said, mostly work for front ends, government front ends, working advanced malware that is later used for your favorite government agency, or even not agency, maybe corporate espionage or criminal activities. Okay.
Yeah, because of that, we all know that about the NSA backdoors, all the time, all the kind of control of our machines, all the kind of software. So from that point of view, who's the bad guys? Who are they? Are we or they are?
For us, it's they, right?
Obviously, thinking about the Tor network, obviously the media network says that they are for criminals because they are not tracking our.
Okay, so it's a more philosophical question. It's the question, what are your values? If your values are personal privacy and personal freedom, then anybody who tries to reduce your privacy, implement 1984, would be a bad guy. So that would be from my perspective. If there are some government people who actually believe that the society cannot be trusted and must be closely monitored, that's their philosophy. And they might consider different people to be the bad guys. And fortunately, we live in democratic society, so I guess we can just decide.
Obviously, the controllers wants to be always the controllers.
Okay.
So they push they put our on our side or the other side, the other people to compromise the controlling systems. They are the bad guys. We have to persecute them. So are we doing fine or not?
So are you asking my personal view
Yeah.
on this?
Yeah.
Well, I value freedom and privacy more than safety. Like these days, the safety is used or overused to implement all sorts of stupid things on you. From airport security checks to everything, like videotaping you in every restaurant or street. So I don't like it. For me, that's wrong. I believe the society does not need to be, we as a society do not need to be so strictly controlled. And still, I hope the world will survive.
Hopefully.
So-
1984 is right now.
Exactly.
Right now.
Exactly.
Right here.
Yes. And I've been reading about, it's so sad, the 1984 by George Orwell, the book, and I've been reading about it like, I don't know, 15 years ago in school, and now I see it, and when I was reading about it, I was like, nah, this like poor people in this book. I felt so much empathy towards them, and I was like, I'm so glad this is not the real thing, and now it is the real thing, as you said.
It's so scary.
Which is scary, yeah. However, one thing I just thought I should have said that probably we should not. So, as I said, lots of offensive, very sharp people sometimes work for those shady company, government fronts, or what other things. It's probably a mistake to to go and tell them, oh, I know you have worked for company XYZ 2 years ago. Now I don't want to talk to you because you're bad, you're evil. So probably it's not good to do this kind of rejection. Yeah. Okay, any more questions? No? Do we have a microphone? Maybe people are shy because there's no microphone. Oh, there's a microphone here. You can just raise your hand and yeah, there's a gentleman in the middle.
Hello, good morning. I have a question regarding Cubes OS. You mentioned that it offers a different approach regarding security or regarding the another operating systems. And I would like to know if you could summarize a bit which is the different approach, the most significant differences between Cubes OS and the other operating systems, if possible.
Okay, so the question was, can I quickly summarize what's so special about CubeOS, the project we've been working on for some years?
Yes, please. Thank you.
Versus the other security solutions. So I try to explain Cubes on two levels. Level one is CubeOS is about isolation or compartmentalization of everything. That's why the name cubes, like lots of little cubes that contain different things. We can have cubes for networking stack, USB stack, all sorts of user domains like personal, banking, work, Project X, Anon, browsing, etc. So that's level one of understanding cubes. Cubes is about isolating everything from everything, and so managing the risk. If my browser gets compromised in my personal domain, then my offline work VM, where I prepare a confidential report, might not get compromised. This is pretty obvious, and I think the concept is very old, nothing new, except that we try to do this isolation reasonably good, and we use the Zen hypervisor, the Zen bare metal hypervisor for that. However, the second level of understanding that most people forget about is that Cubes is for desktop systems, for laptops, desktops, for client systems. Is our laptop is just one laptop. There's just one user. So everything, even though we might compartmentalize first everything, then we need to somehow integrate it back. We want to have one desktop. We have one monitor, one keyboard. There's one network, one physical networking stack, one physical USB stack, for example. So here's the challenge, how to securely integrate all those little compartments back into one usable desktop system without sacrificing security. For example, without using FAT, inter-VM communication protocol, or without exposing X-server protocol to untrusted VMs. And I would say 90% of the challenge with cubes is how to do this integration securely. And that's kind of
Thank you.
short explanation of cubes.
Hello. Do you think security must be a transparent layer for normal users, or they must know how to secure themselves?
Yeah, so that's a hard question. I don't really have an answer to that right now. So if you look at cubes, it has an opinion of being difficult to use at this stage. I like the analogy that cubes currently is like a sports car with manual transmission, rear wheel drive, so might oversteer on turns, so you need to be kind of a good driver to drive it fast and to get most of it. Ideally, we can turn it into a modern sports SUV with electronic transmission without really sacrificing performance. this is what modern cars do. It's difficult. It's difficult to introduce this, to move security under the hood or to become transparent and still not sacrifice it. So lots of work we are planning now is about how to make it easier to use. Ultimately, I think there will always be some requirement for the user to be aware of some things. Like we are in normal our life, while we do not necessarily trust every stranger with everything, we are on the other hand not very paranoid to everybody. We live in a secure society. Still, we have some kind of notion of what we shouldn't do, like, leave our apartments wide open or get candies from strangers, right? That's kind of the answer.
Okay, thank you.
Any more questions? No? Okay, thank you very much.
Bueno, parece que no hay más preguntas para Joanna. Thank you, Joanna, for this conference. I'm sure the people have liked